Let me know when you're done.
Yep, ready.
Now, most of you got this right, these two. However, your solution wasn't that convincing, except maybe one or two people gave me a more convincing reason why their answers are the answers. Okay? So you got your answer. What is that popular answer that everybody got? Which is correct, by the way. What were those answers? -1, 3. For this one? 5. And for the second one? And the other? Okay. So most of you got this, but yeah, it wasn't that convincing. So here is one way to go about it. Somebody mentioned symmetry because of the property that if it is an even, it is symmetrical along y-axis. Somebody mentioned that, which we can accept that. So if it is symmetric along y-axis, if you use that to explain, then maybe yeah, that might be considered. Some people offer no explanation. They only say, oh, this and this and this are also points on the graph. So this is what you can do. Somebody actually did that, or maybe one or two people did it that way. Today's 14, yes?
Yes.
Or 15?
14.
Oh, what is wrong with me? I'm 15 today. Okay. So, to start with the correction. The purpose of this correction is actually to just make you see how you could argue. Okay? I'm not saying you have not done right. Don't get me wrong. So 1a. Because it is even, what is the property of an even function? Since f of x is even, it implies that what? F of negative x equals f of x. Now, what does 1, 3 mean in terms of this function? F of 1 equals 3. Now, if this is x, it means the negation is also the same. Remember that f of x actually means y, right? The y value, the output, like this. It means f of negative 1 is also 3, agree? Which means negative 1 and 3 also can be found on that graph. Does that make sense? This and this must be the same, right? Take this as your x. It means it must have the same value with when you negate the inputs. So we negate the inputs, but we must keep the output constant because they must be the same. So from this, you got this, right? Now, from this, we can write something similar. So what is that similar thing? When x is negative 1, y is 3. And that is how you can justify the first one. This simple stuff is okay. Some of you were able to communicate, oh, it is symmetric. So take, for example, something that is symmetric along y-axis. If I have my 1, 3, x is 1, y is 3. Because it's symmetric along y-axis, I have another one here. Y is still 3, but this time around x is negative 1. Symmetric means it is mirror image, right? But, you know, you don't want to draw all the time, explaining stories. This is sufficient. Start by stating this property, then use it for the first one. So similarly, minus 5 minus 2 implies that f of minus 5 equals negative 2, right? Now, by that even property, what does that mean also? Okay, maybe I want to write this clearly. This implies that f of what? 5 is also equal to negative 2. So you can write here since, because I told some of you I needed to see reasons. I'm going to write the first one again, sorry. So I can practice what I'm preaching. reasons must always be included in your work. Trying to manage this space also. Alright. Since this it implies that f of x equals f of negative x. Okay? I swap it around because of what I intend to achieve. It doesn't matter which one comes first anyway. Okay? Now, then the first one. 1, 3 implies f of 1 is equal to 3. Okay? Now, because of this, you now say this implies that f of negative 1 also equals 3 by this property, since, okay, f is even. We need to state the reason per line. The reason for this line is f is even. This is as a result of this one. Now, this now gives us what? Minus 1, 3. It's also there. Does that make sense? Okay? So you can just write in word. This is minus 1. What was that question again? It's also a point on the graph. So this is okay to, it's okay to write like that. Okay, it's also a point on the graph. Remember we talked about this as a relation. Right? The relation is a set of other pair. Remember that? So that's why I'm writing this way. If you're not comfortable with it, just say this is also a point. A point, right? Or maybe we can write the conclusion later. That's the first one. This implies this. I think it's better, please. It's better. I'm sorry. Then the other one, quickly. What's the other one? Negative 5, negative 2. That implies f of negative 5 is equal to negative 2. This implies what? F of 5 will be equal to, you see, this is x and minus x. And they must be the same. Because what? F is even. It's an even function. Okay? And this now brings what? 5 minus 2 as another point on the graph. Okay? So the 2 points are this and this. We don't have to write again. Any questions? So similarly, for the odd one, B. So we start by saying, since, is that F or G? G. Since G is odd, what does that mean? G of x will be negative G of negative x is G of x. Right? G of negative x is negative G of x. Can I write this in another way? It means when G acts on any x, what does that give you? I'm trying to isolate G now. Negative G negative x. This might be useful for easy manipulation, maybe. Let's see. Now, we are aware that 4, 6 is on the point. 4, 6 implies what? G of 4 equals 6. Now, from what we have just written here, if you put a minus outside and put a minus inside, you still get another one. I'm trying to make sure I have G of something so that I could easily, just like I put here f of something, not starting with f of minus. I don't know if you are getting my point. When we stated the principle, we said f of negative x is equal to f of x. This is all we use, right? But it's easy to see f of 2. So why not just write it in terms of f of x so that we can connect directly that x is 2. That's the purpose of writing it in this form. So I'm trying to do the same thing for g. So instead of g of negative x equals negative g of x, let's isolate this by dividing by negative. So the negative comes here. Am I making sense? So when we say this, we could see clearly this is our x. Then what happens on the other side? We start with what? Negative. Because we still have to get the same 6. Right? Hello? Am I making sense? Yes, because these two have to be the same, right? So we start with negative, then g of what? Negative 4. Am I making sense? So what I have done here, this point and this, I have used here and here. Can we see that? So then the minus goes away. So g of negative 4 equals what? Negative 6. So what is the point? Minus 4 minus 6 is also a point in g. This is because g is odd. Are you confused? You understand? They're just hungry. You need chocolate. Does this make sense? Okay? Calista, any problems? No. And for the second, because we have negative 1 and 2, in G, it implies G of negative 1 equals to 2. Yes? So, tell me, what is the next line? By this property, that G is odd. What is the next one? Negative G of negative 1? 1. That's minus outside, then negation of inside. Minus outside and negation of inside. Must be the same thing as that. Because G is odd. Okay? And now G of 1 equals negative 2. Which implies the other point is 1 minus 2. And that's how you got the other one. So like I said, your answers are right. Just your presentation and the explanation is not that convincing. Okay? Everybody seems to be okay with number 2. Vena, did you see my comment on number 2? You tend to compare both sides in both 2A and 2B. But you can only do it for 2A, not for 2B. I hope you understand the correction, so there's no need to do that. Before you can compare polynomials, we said something. They must be of the same degree, isn't it? They must be of the same degree, and their corresponding coefficient must be the same. But in the case of 2B, there is something different, right? Can I see your 2B? So on the left, you had, okay, yeah. On the left, you had, yeah, they look similar. So your comparison, if you compare, you have to compare the constant, I think. Then you can have 1 plus b equals negative 1 minus b. So that was the only minor mistake. Every other thing seems okay. Otherwise, you can also say, I bring everything to one side, okay? And some things we cancel. I think everybody got b is equal to 1. Yes? Negative 1. Yeah, my bad. Maybe I haven't gotten those. Okay, so that's that about 2. 3. 3 seems to be okay for most people as well. Raise your hand if you couldn't get 3. Oh, there's one thing about 3 and 4. 3 and 4 seems to be similar, and I only noticed some minor stuff. It's just, again, your the way you explain. Lillian, you notice what I wrote. While you offer explanation, you offer explanation for step n by writing it in step n plus 1, or maybe step n minus 1, not in the exact position. For example, here, this means this because of this. In your solution, this reason here, you put it here. As if it's meant for that line. Do you get my point? So that's the only thing. Every other thing looks perfect there. What's going on? Let me go around. Otherwise, people are going to sleep if you don't give them. Okay, quickly. We don't want to waste time. I think we can still make use of this. Miss V, we're still going to make use of this part. Alright, so quickly. Question, I'm going to do question 4. Guys, please. I'm going to do question 4, which is similar to 3. So we're not going to waste too much time. Question 4. Let f and g be odd. F and g are odd. So what does that mean? It means, so we know that f of minus x must be equal to minus f of x. Or should I say, since f and g are odd, it doesn't matter. And g of minus x is equal to negation of g of x, since f and g are odd functions. No. Okay, quickly. So what do we want to show? We want to show that the composition f to g is also an odd function. So in this case, I've already told you must get an odd. So you're working towards that by starting with the composition. So you start by saying f composed with g of x equals to f composed with, like that. This is just by definition, so there's no need to write anything here. But for your next line, we'll start with negation. Right? But for your next line, you want to evaluate this. This is f. So what does this one give? It gives, remember, what you have inside here is exactly this. So you change it to this. And that gives negative g of x. Am I right? This is where you put your reason. We are doing this because of what? You are able to write this because of what? Because g is odd. So since g is odd. So you are supposed to write that reason immediately by that step. Then, your g of x is now a point that f is acting upon. And you have a definition also for f. When it is acting upon a negative point, the negative comes out. So this could be negative f g of x. You are able to write this step because of what? F is odd. Can you see that? So now, by just mere definition of writing this using the composition symbol, this will now be negative f composed with g acting on. And by this, it means that f composed with g is an odd function. So while most of you got the logic, I couldn't see these reasons. That's the only thing. Somebody wrote everything on a straight line. No, please. Especially when reasons are meant to be stated. So connect each step by saying, oh, this implies that, or I'm just saying this one is equal to this, and that is equal to this. So if I want to repeat this, I'll just use implies. This is now equal to implies. This is now equal to something like that. But I could just write it once. Okay? So our communication, yes.
Do you write G is on or G of X is on or it doesn't matter?
Now, G, good question. G is the name of the function. X is just a point. It could be G of A. It could be G of P. Okay? So it's okay to write it either way. Alright. Number 5. Under what condition is this cubic function odd? Just follow the definition and have it on both sides. Just like you did in this question. Everybody, just like you did in question 2. That's exactly what you need to do in question 5. In your question 2, which one is odd again? 2b. In your question 2b, I bet you did g of negative x equals g of x, right? Then you expanded this, then you did something. That's all you have to do here. Well, why some of you did something perfect in number 2, I don't know why you didn't use that principle in number 5. Some of you gave me inequality. Not exactly, because you're supposed to get 0. Okay, so we're going to look at that quickly. Then, is there anything in number 6 to be looked at? Yeah, just 1 or 2 observations also in number 6. Like I said, not so bad what most of you did. Just you need to be more convincing in your solution. Okay, so let's look at quickly question 5. Is it 5? Yes, question 5. Okay? Let's pay attention. Under what condition is this cubic function g of x ax cubed plus bx squared plus cx plus d, where a is not equal to 0, otherwise it's not a cubic anymore. Under what condition is this going to be odd? I'll start by saying this is odd if g of negative x is equal to g of x. That's my preamble. If you want me to show this, this must happen. And that implies, so on my left, I change all x to negative. A negative x cubed. B negative x squared. C negative x. D is just D. On my right, yes ma'am. Oh my bad, I didn't get it, I'll slip again. Okay, thank you. Good job. Pretend this is chocolate and have it. Okay, so on my right you have minus of everything. Ax cubed, bx squared, cx plus d. That's all you have to simplify because that's what you did in number 2. So I don't know why some of you didn't do that in number 5. So this gives, remember for the odd powers, negative is retained. And for the even power, negative is absorbed. Yes? Minus cx plus d minus ax cubed minus bx squared minus cx minus d. So, can anything cancel? Yes. Anything that looks the same on both sides will be eliminated. Yes?
Yes.
So we are left with, this implies that bx squared plus d has to be the same as negative bx squared negative d. So this is where our condition comes out. So we bring them together. Bx squared plus bx squared plus d equals to 0. Okay? Or I can say when b is equal to negative b. And when d is equal to negative d, I think that is even easier when you compare the polynomials. If you do what I just did, you factorize, so you get 2bx squared, then that will be, on the other side is 0, so 2bx squared is equal to 0, which means bx squared is equal to 0, something like that. That's another thing to do. So here you can just compare when b is equal to negative b and when d is equal to negative d. So here, this will be 2b equals to 0. Yes? So this means when b is equal to 0, and similarly, 2d is equal to 0, which implies when d equals to 0. So this is the condition. Okay? And finally, question 6. Now, the only problem I have with some of you with 6 is that you label this f again. That doesn't make sense. Because we're used to f in the definition. Oh, f is odd because, so a lot of people call this is equal to f. So they evaluated f of negative x. F of negative x is already here. So give it a different label. Do you get my point? So give it a different label and you'll be all right. So for that, we could have something like this. So for 6a, so I can say let's, the first one, 6a1, let that function be g. Let g of x be f of x plus f of negative x divided by 2. Let this be g. So your goal is to show that, to decide whether g is odd or even or both. So you start by evaluating, and since, okay, I'm writing my because now, the reason, even though the reason is a calculation, okay, since g of negative x equals to f of negative x plus f of x now, because that will be negative negative x. Understood? Divided by 2, which you can just rearrange. Somebody wrote, because addition is commutative. Brilliant! A plus b equals b plus a. That's commutative property. You know what I mean? Commutative. Is it cu or co? I think it's commutative is addition of everything. Commutative property is co. Yes. Am I right? Commutative property is this. Are they the same?
Yes.
So there was a day I was explaining binary operation, right? Then I said inverse element, identity element, and things like that. There are some properties that comes with it, but because it's not in our syllabus, I didn't want to waste time. An operation, this property is defined, we talk about it in terms of operation. Okay? An operation is commutative if when two operands are operated in any order, you still get the same output. So we say addition is commutative, multiplication is commutative, of course in numbers. And of course, even those numbers are limited. Just the number that you know, let's put it that way. Okay? The numbers that you know. Alright? So it's commutative. Product of matrix is not commutative. Remember, because A times B is not the same as B times A all the time. Composition of functions is not. Because F composed with G may not be G composed with F. Okay? In any case where you rearrange the operand, union of sets, is it commutative or not? Union of two sets.
Yes.
Is it commutative? Yes. Because A union B is the same as B union A. What about intersection? Yeah, down. The car. It is. What does intersection mean?
Oh.
The common element, isn't it?
Yeah.
So whether I say the common element between set Nakita and set Karen, or I say between set Karen and set Nakita, doesn't really make any difference. So intersection of two sets is also commutative. So that's what commutative is about. So somebody mentioned that and said, because addition is commutative, it's the reason why I decided to arrange it this way. And that makes so much sense. So this is f of x plus f of negative x. So commutative property of addition allows us to rearrange it. But what does this mean? This is exactly your g of x. So since your this and this are the same, it implies that that function g is even. Okay? And similarly, we check the other one if it is odd or even. 2. So I call this g, so maybe I call the next one h. Let h of x be f minus f negative divided by 2. Then I say, since h of negative x, I'm going to see what happens to h of negative x. Okay? Since h of negative x is f of negative x minus f of x divided by 2, this is just by substitution. Okay? So this is positive, I bring it first. Unfortunately, the positive happens to be negative, a negative term, while this is a positive one, divided by 2. So there's no commutative in this case. Now this minus is still within this line. Let's look. This minus is not out, it's still within this line. If I need it out, it's more or less putting a bracket. Okay, then I can say f of x minus f of negative x. Now the minus is factorized. And if you look at it, what you have here is the original function. So which means it is negation of h of x itself, which implies that h must be an odd function. So the bigger issue with some of you is you call this f again. So that, but your idea is logical. It's just your presentation. So finally, prove that f of x can be written as sum. It's easy. Because it's continuation. So you know they are linked. So basically, this is your even and this is odd. Add them together to see. Okay? Add them together to see. And of course, if you add them together, you could see that it gives you f. So for this, B, prove that f can be written as a sum of two odd functions. So I could say that f is equal to twice f. If I want to go the extra whatever. This is not what some of you did. Some of you said, okay, this is even and this is odd. You had them together and you got f. That's okay. I could start from f and try to work my way around it. And that's what I'm trying to do. It's just the reverse of what you did to make it look extra smart. It's not about being smart, it's just being tricky. Okay? So f is 2f divided by 2. Right? Then I'm going to say 2f of x. I'll add something and subtract it immediately. So because I already subtracted, you have no reason to crucify me. Oh, why did you change my question? No, I just put it there and I took it away immediately. It's like writing rubbish in your note and erase it immediately. Do you get my point? Just to achieve my aim. Okay? A bully sometimes will do that, writes rubbish and erase it, and when the teacher says, no, I already erased it. It's just trying